Okay, chapter 5, coordinate geometry. A lot of what we're going to be doing is, again, from GCSE, sketching straight line graphs, calculating points on a straight line graph, calculating lengths using Pythagoras, and then something that's a little bit new is finding the areas made by straight lines. Okay, then obviously we're going to be, you've got your success criteria abstract, which being able to explain these will show our higher order thinking skills and full understanding. So, we know that the equation of a straight line is broken into gradients and y-intercept. But we also need to be feeling comfortable with equations of straight lines that are vertical or horizontal. The equation of straight line, no matter any coordinate which I pick on this straight line, okay, so if I pick this one, we see our x-coordinate is 2, minus 3. If I pick this one, 2, 1. If I pick this one, 2, minus 1. All of them have the same thing in common. This is the line x equals 2, okay? And we should be very confident with that. If I was to draw this line here, as you can see, it's perfectly straight. If you see it's wonky, you need to get your eyes tested. Okay, here, what is this straight line? Y equals minus 2. So, what we can do is to find any coordinate on a line, we can use substitution. If it tells us that the equation of a line is y equals 3x plus 2, it says determine the value of a, because this point lies on this line. So when x equals 5, what is a? Well, a is our y coordinate. So when we use substitution, we're going to get y equals 3 lots of 5 plus 2, which is 17. So therefore, a equals 17, so our coordinate is 5, 17. Find the coordinates of the point where the line 2x plus y equals 5 cuts the x-axis. Now, if we think about, we have our x and our y. If we're cutting this x-axis, the x-axis is actually the line y equals 0. So whenever it says it cuts the x-axis, that means when does what coordinate when y equals 0. So we're going to have 2x plus 0 equals 5. So then we're going to have 2x equals 5. So x equals 5 over 2. Okay, so my coordinates where it cuts the x-axis is 5 over 2 and 0. And you can see even 5 over 2 is 2.5. I've kept it as a fraction. We love fractions in A-level mathematics. So if it did say, find the coordinates where it cuts the y-axis, that means we want to find when x equals 0, because the line on the y-axis is when x equals 0. Okay, so test your understanding. You've got 2 questions to do. Okay then, so y-axis, when we're crossing the y-axis, x equals 0. So we're going to get 2y equals 3, y equals 3 over 2. So our coordinates is 0, 3 over 2. When it crosses the x-axis, our y equals 0. So that means we're going to get x equals 3. So our coordinate is 3, 0. This should have been really nice and simple. The mistakes that are easy to make here is that when people say it crosses the y-axis, they put y equals 0. Okay, it's a really silly mistake and shows no understanding. Please make sure you understand what's going on here. Okay then, so we know our gradient, and someone said it earlier, for every one along, we go up m, okay? Another way to put it is our difference in y over our difference in x, okay? And we know there are certain ways we can work out the gradient. Some people like to count the squares, but really if we have 2 points and we don't have an equation, it is y2 minus y1 over x2 minus x1, and we should remember this from GCSE. So, if we're calculating the gradients, remember your x1, y1, x2, y2. So our gradient is going to be m equals 10 minus 4, because remember it's y2 minus y1, over 3 minus 1, which is 6 over 2, which is 3. Okay? So what I would like you to do is I'd like you to work out the gradients for 2 and 3 very quickly. Okay then, so what we're going to have for the gradient is we're going to have 1 minus 7 over 8 minus 5. 1 minus 7 is minus 6. 8 minus 5 is 3. Minus 6 over 3 is minus 2. For the second one, we're going to get 10 minus 2 and minus 1 minus 2, which is 8 over minus 3. So minus 8 over 3. Now, part 4, to show that the points A, B, and C all lie on a straight line, we need to find the gradient, okay, the gradient of AB and the gradient of BC. Because they have a common point B, if the gradients are the same, they will be on a straight line. Can you quickly do that for me, please? Okay, so the gradient of AB is going to be 1 over 2. Because we're going to get 5 minus 4 over 5 minus 3. And then the gradient of BC is going to be 8 minus 5, which is 8 minus 5, which is 3, and 11 minus 5, which is 6, which equals a half, okay? So, the gradient of AB and the gradient of BC are equal and share a common point B, therefore all lie on a straight line, okay? And you'll notice that that is what we used to do when we were proving 3 vectors, 3 points, you know, when we did vectors lie on a straight line. Okay then, so the line joining 2 minus 5 to 4a has a gradient of minus 1. Work out the value of a. So this time, they've told you that the gradient, so we know that m equals y2 minus y1 over x2 minus x1. They've told us that our gradient is minus 1, so minus 1 equals, our y2 is a, minus our y1 is minus 5, over, and then we're going to get 4 minus 2. So all we're going to literally do is substitute in, remember our y2, is substitute in everything that we know and then work it out. Okay, so you can see I'm colour coding it for you. Okay, but again, we should be confident with this from GCSE. Let's get a pink. Okay, so we've substituted everything in and then you just need to work it out. So we're going to get minus 1 equals a plus 5 over 2. So minus 2 equals a plus 5. So a equals minus 7. Perfect. Okay then, so one form we can put a straight line equation is sometimes we have y equals mx plus c. But sometimes they want to have ay plus bx plus c equals 0. So all they've done is substituted it around. Sometimes they give us that form. And we need to be comfortable putting it into this form. Essentially, we are rearranging. Yeah, so they actually put it in ax plus by plus c. But as long as we know that the x and y are on one side with the y-intercept, that's all we need to focus on. So here we have determine the gradient and y-intercept of the line 4x minus 3y plus 5 equals 0. As we've seen earlier, this isn't the form that we like to find the gradient in. We would like it to be in the form y equals mx plus c. So 4x minus 3y plus 5 equals 0. I'm going to rearrange this to get negative 3y equals negative 4x minus 5. I'm then going to divide everything by minus 3, so I'm going to get 4 over 3x plus 5 over 3. So our gradient is 4 over 3, and our y-intercept is 5 over 3. Okay, this is just simple rearranging. So then, what you're going to do, sometimes they ask you to put it into this form at the end of the question. If you don't do this, you do lose a mark. Okay, so you can see here, we have y equals a third x minus 2/3. It wants it in the form ax plus by plus c, where a, b, and c are integers, so we cannot have fractions. Luckily, all of these are over 3, so we're going to multiply the whole equation by 3. So that means I'm going to get 3y equals 1 over 3x times 3 is just x, minus 2 over 3 times 3 is minus 2. I'm then going to rearrange it so everything's on the left-hand side. So I'm going to get 3y minus x plus 2 equals 0. It wants me to put my ax first, so I'm going to get minus x plus 3y plus 2 equals 0. And because, okay, I want to make it easy for the person that's marking my work, our a is minus 1, our b is 3, and our c equals 2. So, quick question, off you go. Okay, so nice and easy. We have y equals 2 over 5x plus 3 over 5y. Luckily, the denominators are both over 5. If I multiply the whole equation by 5, I get 5y equals 2x plus 3. I'm going to rearrange it so everything is on the left-hand side. Minus 2x plus 5y minus 3 equals 0. Okay then, so let's find the equation of a line that goes through the point 3, 5 and has a gradient of 2. Now there is 2 ways, well, I'm going to show you 2 ways, but there's a few ways to do this. Okay, way number 1. You know y equals mx plus c. You know that, okay? So, y equals, and in this case our gradient is 2 because it's told us 2x plus c, okay? It's told us the gradient is 2, so I can substitute that in. And then we're given a point. Now we know when x equals 3, y must equal 5. So I can substitute them in. 3 equals 5 equals 2 lots of 3 plus c, okay? And again, this is our x coordinate and our y coordinate that I've substituted in. So then I've got 5 equals 6 plus c, so minus 1 equals c. Therefore, our equation is y equals 2x minus 1. So there's one way to do it. And that way works for the majority of the time. There is another way to find out the equation. Okay. Does anybody know the other way? So the other way to find the equation is if you had 2 points. Okay. You can do y minus y1 equals mx minus x1. Sorry, not 2 points, a point and the gradient. And then what you're going to do here is we're going to substitute in. So we're going to get y minus 5 equals 2 bracket x minus 3. Okay? And that's because our x coordinate is our x1, so you can see I've put the 3 in there. Okay. Our y coordinate is our 5, okay, which is our y1. and our gradient is 2, okay? So you can see these are the only things, our y and our x stay the same. And then I'm going to multiply this out. Y minus 5 equals 2x minus 6. So y equals 2x, and if I add 5 to both sides, I get minus 1. Okay? Both ways will give you the same answer. Okay? So this is essentially a formula, or this is a formula, either or. Sometimes it's up to you which one you prefer. Okay? You still need certain pieces of information for both. I really don't mind which one you use, but sometimes I will use one more than the other and the other more than one. Okay? So here we can see, this is the equation that we've just spoken about, okay? That if we have a point x and y and we have a point x1, y1, okay, we know our gradient, and this is where, you know, we have our y2 minus y1 over x2 minus x1. It's just a rearrangement of that, okay? This is where the formula comes from, so we can use that method. So then, if you have a gradient and a point, you need to be able to find the equation of the straight line. Anyone get that for the next one? Yeah? Okay, then for the next one, I'm going to get y equals a half x. So we're going to have a half. So minus 11 over 2. Or maybe not. Oh, yeah, sorry. This is minus 15, yeah? Okay. A half x minus 11 over 2? Yes or no? And then we're going to get y equals 9x. 9x plus 32. Okay then. First of all, we know that we need to find the gradient, don't we? So using our formula, I found the gradient, y2 minus y1 over x2 minus x1. And here I have the gradient. Then I decided I'm going to use the form y equals mx plus c. So I used y equals mx plus c and I substituted in my gradient. Now from the slide before, what you realise is I chose one of these points to substitute in as my x and y to find my c. I could have chosen 4, 5 here and I still would have got the same answer. So I'm going to go through this example. I'm going to go through the other question with you. So when you're given 2 points, step 1, we're going to find the gradient. Okay, so we're going to have 5 minus 9 over 4 minus minus 1. 5 minus 1 is negative 4. 5 minus 9 is negative 4. 4 minus minus 1 is 5. So our gradient is minus 4 over 5. So now I can either use, remember we have 2 ways to do this. We can either do y equals mx plus c, or we can do y minus y1 equals mx minus x1. I really don't mind which way you want to do this, okay? You need to be confident with both. But if we do this one, we know our gradient is minus 4 over 5. So I'm going to get y equals minus 4 over 5x plus c. I can choose either point to substitute into here to give me c. Both will give me the same value of c because they lie on the straight line. So if I choose minus 1, 9, I'm going to get 9 equals minus 4 over 5 lots of minus 1 plus c. So 9 equals 4 over 5 plus c. Okay. 9 minus 4 over 5 is 41 over 5. Which equals c. Okay, so I've done that in my head, but you can just type into your calculator 9 minus 4 over 5, can't you? Yeah? So then, that means that y equals minus 4 over 5x plus 41 over 5. It wants it in the form ax plus by plus c. I want integer solutions. So they have a common denominator of 5, so I'm going to multiply everything by 5. 5y minus 4 plus 4x minus 41 equals 0. Okay, and that's just rearranging it. And these steps we looked at earlier, so we should be confident with that. We could have done this a different way. Once we figured out our gradient, we have y minus, and I can pick, if I can choose the 0.45 this time, so y minus 5 equals minus 4 over 5 x, and then I'm going to have minus 4, okay? Now what I'm going to do is I can expand out and multiply everything by 5. I'm going to multiply everything by 5. 5y minus 25 equals minus 4x plus 16. So then if I rearrange everything, I'm going to get 5y plus 4x, and minus 25 minus 16 is minus 41 equals 0. I get the exact same answer. So for this one, our gradient is 2, so we know y equals 2x plus c. Nice and easy. And it's given us 2 points, 2 and 5, so we know our y is 5 equals 2 lots of 2 plus c. 5 equals 4 plus c, so 1 equals c. So that means y equals 2x plus 1. If you're happy with that, the other one is just as easy. Apart from this time, you're given 2 points. Step 1, work out the gradient. So you know to find the gradient, you do the difference in y over the difference in x. So 8 minus 4, because that's 8 minus 4, divided by 3 minus 2, which equals 4 over 1, so my gradient is 4. Okay then, so now this is just like the question above. We've got a gradient of 2. Okay, so look at this question. Gradient 2. Our gradient is 4. And then it's given us a 0.25. Well, we've got two points to choose from. Which one do you want to choose? 2, 4. If you can do this question, you can do this question. As long as you find the gradient first and choose which point you want to do. Because now we go straight into this method. So now we've got our point. We know that y equals 4x plus c. I'm going to get 4 equals 4 lots of 2 plus c. So I'm going to get 4 minus 8 minus 4 equals c. So therefore y equals 4x minus 4 is the answer. Okay, so we can see we've got these answers here. What I would like you to do is finish page 89 and 91. Okay, these are the questions I want you to do. Okay, so the diagram shows 2 lines with equations y equals 3x and x plus 2y equals 4, which intersect at the point P. Determine the coordinates of P. When 2 lines intersect, they are equal to each other at that specific moment. So that means if y equals 3x and x plus 2y equals 4, they are essentially simultaneous equations. So we can substitute one into the other. So if I substitute, I'm going to get x plus 2 lots of 3x equals 4. So 6, 7x equals 4. X equals 4 over 7. So then that means y equals 12 over 7. Perfect. So it then says the line x plus 2y equals 4 intersects the x-axis at the point Q. If it intersects the x-axis, that means y equals 0 at any point on the x-axis. So determine the coordinates of Q. Oh, wait there. For part A, it says determine the coordinates. It's really important that we actually write it in coordinate form after. We don't just write x equals and y equals, okay? That's a very important point. So determine the coordinates at Q. Well, we're going to get x plus 2 lots of 0 equals 4. So x equals 4, so my coordinates are 4, 0. Okay, so the line L1 passes through the points minus 3, 1 and 11, 12. Find an equation of L1 in the form ax plus by plus c equals 0, where a, b and c are integers. Nice and easy. Okay, step 1, we need to find the gradient. We know to find the gradient, we're going to do y2 minus y1 over x2 minus x1, which is going to give me 12 minus 3 is 9 over 12. So my gradient is in fact 3 over 4. Now I can choose any point I want. It doesn't matter which point I choose. I'm going to choose for minus 1, 3. I have my equation y equals mx plus c. I'm going to substitute in everything I know. So y is 3 equals 3/4, because that's my gradient, lots of minus 1 plus c. So I'm going to get 3 times 12, 15 over 4 equals c. So then my equation is y equals 3/4 x plus 15 over 4. Again, I need to change it. So I'm going to get 4y minus 3x minus 15 equals 0. Or yours might be 3x minus 4y plus 15 equals 0. Either or. Okay, for the second part of the question, it says the line L2 has the equation 3y plus 4x minus 30 equals 0. Find the coordinates of the point of intersection of L1 and L2. So I'm going to rewrite L1. 3x minus 4y equals negative 15. And then I'm going to get 4x plus 3y equals 30. Okay? Now, again, you could have written this a slightly different way. Doesn't matter. If I'm going to multiply this equation by 3. I'm going to multiply this equation by 4. So I'm going to get 9x minus 12y equals negative 45. And I'm going to get 16x plus 12y equals 90. Okay? I'm going to add them together. So I'm going to get 25x equals 45. What does x equal? 45 over 25, 9 over 5? Is that right? No. Yeah? Yeah. Absolute classic mistake. It's not even a classic mistake, it's a silly mistake. What's 90 times 4, everyone? 120. So 25x equals 120. What's 120 divided by 25? Pardon? Okay, so 25x equals 75, so x equals 3. Okay, then from there I can substitute y into any equation. So 3 lots of 3 minus 4y equals negative 15. Minus 4y equals negative 15 minus 9 is minus 24. So y equals 6. So the coordinates are going to be 3, 6. And again, where do you get your marks from? It's 3 marks. So you get 1 mark for adding or subtracting your simultaneous equations, 1 mark for then substituting, finding x, and another mark for using that to substitute in to y. So, here we have different gradients, okay, and we're able to work out the gradients. Now, what we should find is the gradients of perpendicular lines, okay. We're going to find that the gradient of one line multiplied by the gradient of the second line, if they are perpendicular, equal minus 1. And we should remember that from GCSE, okay. And here, these lines are perpendicular because they meet at a right angle, okay? They meet at 90 degrees. If we look at this purple line here, okay, the gradient of this line, again, you can do the difference in y over the difference in x. So if I draw this triangle, I'm going to get 2 over 4. So this is going to be a half. Okay, so if this line equals a half, and I know that this line is perpendicular, a half times what equals -1, -2. So this gradient of this line should be -2, which it is, because if we can't really see the whole triangle, but if we were to draw it, okay, we're going to get -4 over 2, which is -2. The other way you can look at when you're finding gradients of perpendicular lines is if you know that one gradient, if you know one of the lines is a half and it tells you the second line is perpendicular, you flip it and put a minus in front of it. So -2 over 1, which is -2. Okay, so you can flip it and put a minus in front of it. But we should be confident that the two gradients multiplied together are going to give us -1. The other way to do it is to, if you want to find it, you do -1 divided by. So if you have M1 and you want to find M2, you're going to do -1 divided by M1. Okay, simple rearranging. So then, very quick fire, okay? Very quick fire questions. If the gradient is 2, the perpendicular gradient, -1/2. If the gradient is -3, the perpendicular gradient, +1/3. If the gradient is 1/4, -4. If the gradient is 5, -1 over 5. If the gradient is -2 over 7, 7 over 2. If the gradient is 7 over 5, -5 over 7. Okay, so all of those quick fire questions. Okay then, so types of examples of problems. A line goes through the equation 9, 10 and is perpendicular to another line with the equation 3x plus 2. What is the equation of the line? Well, if it's perpendicular to this equation, that means our gradient is going to be -1 over 3. Okay, so this is the gradient of the perpendicular line, and you can see I'm putting MP. Okay, gradient of perpendicular, and we've been given a point. So now I can substitute in my value. So 10 equals -1/3 lots of 9 plus C, which then means 10 equals -3 plus C. C equals 13. So the equation of the line is y equals -1/3 x plus 13. Okay? For the second one, a line L1 goes through the points A, 1, 3, and B, 3, -1. A second line L2 is perpendicular to L1 and passes through the point B. Where does L2 cross the x-axis? So it's using all these skills that we know. So step 1, we need to find the gradient of L1. Okay, so the gradient of L1, and I'm just going to put a 1. Okay, so the gradient of 1, we use our formula. So I'm going to get -1 minus 3 over 3 minus 1, which is -4 over 2, which is -2. Okay, so my gradient of the first line is this one. Okay, a second line, L2, is perpendicular to L1. So if it's perpendicular, my gradient of line 2 is going to be a half. Okay, and it crosses through the point B. So it passes through the point 3 minus 1. So it's back to what we did at the beginning of the chapter. We have a gradient, we have a point, we now need to work out the equation of the straight line, which is going to be y equals 1/2 x plus c. We're going to substitute in our values. So we're going to get -1 equals 1/2 lots of 3 plus c. So -1 minus 3 over 2, so c equals 5 over 2. -5 over 2. Okay. So c equals -5 over 2. So there's our equation of the line. And then the last point says, and passes through, where does it cross the x-axis? If it crosses the x-axis, that means that y equals 0. So then I'm going to get 0 equals 1/2 x minus 5 over 2. So 5 over 2 equals 1/2 x. So x equals 5. Okay, but it wants the coordinates. So we're going to do 5, 0. Question 3. Are the following lines parallel, perpendicular, or neither? Now, if they're parallel lines, our M1 equals M2. Our gradients are the same. If they're perpendicular, we know that M1 multiplied by M2 equals -1. And if M1 or M2 doesn't equal each other, or they don't multiply to give us -1, they are neither. So the first one, I have y equals a half x. For the second one, I need to rearrange it in the form y equals mx plus c. So I'm going to get y equals 2x plus 4. Okay, a half does not equal 2, so they are not parallel. Okay, just to make this clear, okay, all I did here was add y to both sides to get 2x plus 4 equals y, and then just writ it the other way. If I wanted to, I could have had minus y equals minus x minus 4, but remember it has to be in the form y equals, not negative y. So I have to divide everything by -1, which is going to give me y equals 2x plus 4, okay? So, a half and 2 are not the same, so it's not parallel. A half times 2 does not give me -1, so they're not perpendicular. So the answer is neither. Perfect. For the first question, our answer should have been 2y plus x minus 18 equals 0. And then for the next question, if the line, this line here is perpendicular, so we know it's y equals 2x plus c, it crosses at the origin. So when we put the point 0, 0 in, we're just going to get y equals 2x. Then we're going to solve simultaneous equations. We're going to put them both together, and our coordinates are going to be 8, 5, and 16, 5. Was it here? Don't know. So, distance between 2 points. What's our favourite mathematician, apart from myself? Pythagoras. Well done, Vivian. So, when we're finding the difference in x, okay, we're looking at our x coordinates, 1 and 5, so our difference in x is 4. And then our difference in y is 9 and 6, which is also 3. So then we're going to have the square root of 3 squared plus 4 squared, which is square root of 25, which equals 5. So our distance between the 2 points is 5. Now, I know when we do square root, we normally do plus or minus root 25, which would give us plus or minus 5. But we reject the -5 because this is a distance. Okay, we cannot have a negative distance. That's why we reject the negative. So then, a few examples. You need to find the distance between these 2 points. So I'm going to do, 7, what's the distance? So look at the difference. So between 3 and 5, it's 2 squared plus, and the difference between 7 and 4, 3 squared, and then we're going to square root it. So we're going to get the square root of 13. The second one, we have the difference between -3 and 1, which is 4 squared, and then the difference between 6 and 5 is 1 squared, which is root 17. Okay, now for the last one, the difference between 3 and -2 is 5 squared plus 0 and -1. The difference is 1 squared, which is root 26. So then we're going to have the square root of 4 squared plus 3 squared, which is 5. We're going to have the square root of 2 squared plus 3 squared, which is root 13. And then we're going to have the square root of 6 squared plus 8 squared, which is root 100, which is 10. Okay then, so sometimes it's going to ask us to find the area of a shape. Okay? So, And the diagram shows two lines with equations y equals 3x and x plus 2y equals 4, which intersects at the point P. Determine the coordinates of P. Okay, we already did this. Okay, so we've already done this. And we have our coordinates of P, because we put them equal to each other. We didn't put them equal to each other. We substituted in, rearranged. So we did get x equals 4 over 7 and y equals 12 over 7. Okay, so we've done the first part of the equation. Part B says the line x plus 2y intersects the x-axis at the point Q. Determine the area of the triangle OBQ. So the line x plus 2y equals 4 intersects at Q. Okay, we did this before. This is when our y equals 0. So here our coordinate is 4, 0. So if I substitute in 2 lots of 0, I get x equals 4. Yeah? So, great news. When we're looking at the area of a triangle, okay, we need the base, we need the height. Now, lucky for us, our base is from 0 to 4. So our length here is 4. Okay, and our height is, 12 over 7. Thank you. Okay. Because it is the y coordinate, because this here is 12 over 7.
So Miss, why didn't you put as your base?
Okay. 4 times 12 over 7 divided by 2, because it is a triangle. So 4 times 12 over 7 is 48 over 7 divided by 2. Okay, which is 24 over 7. So that is the area. And we call this units squared, because whenever we do area, we always have a square in our units. Okay then, so here's another example. Determine the length of PQ. So if we want to find the length of PQ, we need two things. A, we need to know the coordinates of P, and B, we need to know the coordinates of Q. So, to find the coordinates of Q, if we have a look, it's when this line here intercepts the y-axis, so that means x equals 0. So, to find Q, it's when x equals 0, 2y plus equals x plus 4. When x equals 0, I get 2y equals 4, y equals 2. So the coordinates of Q are 0, 2. Perfect. I now need to find the coordinates of P. The coordinates of P happen when these two lines intersect. When they intersect, we have simultaneous equations. Okay, so that's when 2y equals x plus 4, and then I'm going to rearrange the second one to get x equals 8 minus y. Everyone happy with that? Yeah. Substitute in 2y equals 8 minus y plus 4, 2y equals 12 minus y, 3y equals 12, y equals 4, x equals 8 minus 4, x equals 4. So this P is actually 4, 4. So if I know that this point is 0, 2, and this point is 4, 4, if I find the length, I'm going to find the square root of the difference in y, which is 2, plus the difference in x, which is 4. 2 squared is 4, I'm going to get root 20, or I could rewrite that as 2 root 5, simplified. And again, I want us to simplify, and we should be able to simplify that in our head, okay, because this is from chapter 1, okay? Has anyone forgotten how to simplify root 20? Perfect. Right, it now says determine the area PQR. Okay, so the area we want is PQR. So our base Okay? Remember, for a triangle, we need base times height over 2. Our base, I'm going to do in green, is going to be this length between Q and R. Okay, our height is going to be there. Okay, so that's what we're looking for. So our height we already know, okay, because our height is our x coordinate of P, which is 4. Okay, our base, we need to find R. Now, it's when it crosses the y-axis for this one. Okay, so that means x equals 0, so y equals 8. So this corner is 0, 8. Okay, to find our height, we're going to do the difference between 2 and 8, which is 6. So 6 times 4 over 2 equals 12 units squared. Okay, so let's go really quickly. The coordinates of P is where I substitute them together. Okay, so what do I get?
6, 3.
P equals 6. So 6, 3. Perfect. So then so this is 6, 3. My R coordinate is 0, minus 3. And my Q coordinate is 0, 6. Okay. It wants the area of PQR. So I've got my base, which is 9, times my height, which is 6, divided by 2 is 26 units squared. 27 units squared. If you didn't write units squared, you don't get that right. Then determine the length of PQ. Well, here's P, here's Q. My difference is 6 squared plus 3 squared square rooted. 64 plus 9. No, 36 plus 9. Root 45, which is 3 root 5.